Assalamu alaikum, I'm Pavel and I welcome you all to the 7th video tutorial of the calculus video tutorial series. In this lecture, we will discuss about the application of infinite limit into rational function. In the earlier two lectures, we discussed about two cases. In case number 1, we have seen that what happens when we apply infinite limit into a rational function where the degree in the numerator was less than the degree of the denominator, and in case 2 we have seen when the degree in both numerator and the denominators were equal. Now in this lecture we will see when we apply infinite limit in this type of rational functions where the degree of p of x, that is the numerator, is greater than the degree of q of x, where both of them are polynomials. P of x is a polynomial and q of x is a polynomial. Okay, so before I move on, let me tell you one thing. If you are new to this channel, please subscribe to this channel so that I get the inspiration to make more and more videos for you. And if you like these videos and the tutorial series, please let me know your feedback on the comment section. Okay, so let's have a look into some examples. Limit x tends to infinity, x cube plus twice x divided by x square minus 5x. So this is a rational function. The degree in the denominator is 2, that is the highest power of x. Here it is 2, and the degree in the numerator is 3. So we can see the degree of p of x. So we let this numerator, the polynomial in the numerator, to be p of x. So its degree is 3 and its degree is 2. So this is greater than the denominator. Now what we will do is that we will divide all the terms in both the numerator and the denominators with x square. So what happens if we divide this x cube with x square? We get x plus twice x divided by x square, so we will get 2 by x, then x square divided by x square is equal to 1, minus 5x divided by x square, so we will get 5 by x. Now we know that when limit x tends to infinity, then 2 by x, something divided by x or any positive power of x, it becomes 0. As we know that limit x tends to infinity, any constant divided by x to the power n is equal to 0. And if you don't know about this, please have a look into my lecture number 5. I guess I discussed this thing in lecture number 5 or 4. Okay, so with the application of this concept, we can say that this value here, 2 divided by x, will become 0. Also 5 divided by x, it will also become 0. So now we are left with x divided by 1. So this value of x is approaching towards infinity and it's being divided by 1. So nothing changes much. So it's become positive infinity. So we have seen that in this case we will get positive infinity. Now we have a look in some other examples if we do have if we do get some other values or not. So here let me write another example, limit x tends to infinity. So let's give a negative value here, negative x cube minus 7x plus 2x square plus say 9x. Okay, we should not give this plus sign. I mean, it doesn't matter whether we give any plus sign or not. Okay, so what will happen here? This is a similar problem, just a bit change. In this example, we have seen that the leading coefficients, they were positive in both the numerator and the denominator. So what does it mean by leading coefficient? The coefficient of the highest term, I mean the highest power, the term with the highest power, its coefficient is called the leading coefficient. So here the leading coefficient is 1, positive 1, and here the leading coefficient is also positive 1. So that's why we have got positive infinity. But here the leading coefficients are of opposite sign. So now let's see what happens here. We apply the same concept here. We divide both the numerator and the denominator with x square. So we will get negative x here minus 7 divided by x, and then 2x square. So we will get 2 plus 9 by x. Now using the concept that we already discussed, that if limit x tends to infinity, constant divided by x to the power n, which is equal to 0, which was written here a bit ago. So using that concept, we can say that this value is going to be 0 and this value is also going to be 0. So this is 0, 0, this is also 0. Now we have negative x divided by 2. So what happens when x is approaching to infinity? Negative x will become negative infinity because x is increasing, so this negative sign remains in the front and the value is continuously increasing. So for example, x becomes 10, then negative x becomes negative 10, then x becomes 100, negative x becomes negative 100. So in this way, the value, when the values of the x are increasing and approaching towards infinity, it will become negative infinity, and divided by 2 doesn't make any change. I mean, significant amount of change. So it will become negative infinity. So we have come to a conclusion. We can come to a conclusion that when the leading coefficients are of same sign. So you see here it was positive. That's why we got positive infinity. We can say positive infinity. But when we take opposite signs, here it was negative, it was positive. That's why we have got negative infinity. Now let's have a look when we take both the leading coefficients of the numerator and the numerator as to be negative. What happens? Okay, let's have a look. So we just make a change here. We give a negative sign here, negative sign here. So it will become negative x, negative 1. So this value becomes 0, this value also becomes 0. Then this negative sign, this negative sign, negative cancels out. So we will get again positive infinity. So we can come to a conclusion that in this case, case number 3, when the degree of p of x is greater than the degree of q of x, that is, the degree in the numerator is greater than the degree of the denominator, in that case, we will get either positive infinity or negative infinity depending on the leading coefficients. So if the leading coefficients are of the same sign, that is, if both are positive or both are negative, then the result will be positive infinity. If they are of opposite sign, then we will get negative infinity. So if we take, say, positive here and negative here, same thing will happen. So we will get x divided by minus 2. So it's continuously increasing, but when we are dividing any number with a negative value, the quotient will be negative. That's why we will get a negative infinity. So I hope you understood everything that I have been discussed in this lecture. Even then, if you face any trouble understanding any of the concepts, you can let me know through the comment section. Please do that so that I can get a feedback whether my lectures are being effective for you or not. And in the next lectures, we will discuss about limits of exponential functions. So I welcome you all to watch that videos. Till then, take care. Allah Hafiz.